been some interested from. That's the new one now.
That's the new one?
All right, welcome back. So since we've been here, we've actually heard from a lot of different speakers. We're coming up to the last session, and we have now realized that we eat, sleep, and breathe PFAS. So what we're going to talk about in this session is unraveling the PFAS contamination. So we're going to hear about forensics analysis, data evaluation, and some remediation optimization. So with that, we will bring our first speaker up. We've got Bryan Massa from LSP from HRP and Associates. Going to talk about identifying the sources of PFAS detected in municipal drinking water supply wells.
All right. Hey, everybody. All right. My name is Bryan Massa. I'm a licensed site professional with HRP Associates. I'm out of our Massachusetts office. And I'm going to give you guys a presentation on the use of environmental forensics to determine potential sources impacting a drinking water supply well system in Massachusetts. So in 2021, PFAS was detected in 12 municipal drinking water supply wells in a southern Massachusetts town. One of the PFAS detections was about 5 times the regulatory standard. In Massachusetts, we've had PFAS regulatory values for drinking water since about 2018. And we use a little bit different than EPA. We have what's called the sum of 6, and it's 20 parts per trillion. PFAS was also detected in the other 11 wells at concentrations ranging from 2 to about 16 or so parts per billion. The PFAS source was originally unknown. The town was obviously pretty concerned. They shut down the municipal drinking water well that had exceeded the regulatory supply, the regulatory standards, and we're starting to wonder what could be the potential sources. When we got involved in the project, we took a quick high-level look, and there was a couple potentials that we wanted to dig deeper in. First was that there was 2 municipal landfills that were within the town. There's no sanitary sewer system in this town. It's all septic systems, so that was a potential source as well from both residential and commercial use. Atmospheric deposition, I know we've all talked about that. Atmospheric deposition is definitely a known PFAS source, and a lot of research in this in Massachusetts has been done, and we have identified that there is PFAS in background soils related to atmospheric deposition. Aerial application of insecticides. A study was also done in Massachusetts that determined the use of mosquito spray for mosquitoes control did contain PFAS. Also potential undocumented release with the Mass DEP. So in Massachusetts, there's a pretty good regulatory program in place where you can go onto websites and monitor where there's been known releases. You can even search for contaminants. But there's always a potential that there are sites that we just don't know about. Final thing too is there's a couple fire departments in town, and again, everybody knows that AFFF is a significant source of contamination. So We gave a couple different things that we could do for a citizens group. This was actually originally brought in by a citizens group who requested a grant from Mass DEP to kind of look into this so that they could help figure out what was causing this impact, so that they could help the town, address that. So the objective of this exercise was to develop a concise picture of how PFAS are moving through the groundwater to the municipal supply wells and identify the likely source or sources. So the methodology was to use an environmental forensics analysis using several lines of evidence. So first was a cursory review of North American Industrial Classification System users. So there's some tools out there. Mass DEP has a database, so does EPA, where you can review potential PFAS sources related to business NISAC codes. Second was a review of regulatory records to see if there were any known documented PFAS releases in the area. GIS mapping to kind of place all of these things on a map. Review of analytical data. The town was collecting quarterly groundwater data from all municipal wells, so we had a couple years worth of data to work with. We also wanted to look at any analytical data that was available from the landfills. Because it was in a regulatory program, data was available. We wanted to develop PFAS signatures. So one of the things that we've been doing is generating forensic signatures of PFAS to figure out distinguishing characteristics between them. We use radar plots. People use histograms. There's multiple different ways that you can do it. We also wanted to determine what the PFAS background was in the area, because we know that there's PFAS in groundwater that's related to just our general everyday life. It's in all of our consumer products and other things that we use. So we wanted to find out, is this a background issue? Maybe this is just related to septic system usage and other things. We also wanted to do a hydrogeologic evaluation with particle tracking to figure out potential connections between sources that we've identified and the drinking water wells. All right, so we have 5 steps that we basically decided that we would do to kind of come up with the potential source of the release that was identified. So the first step is, let's identify the area that we're looking in. We were looking in the entire town. There was no known area, so we said, well, let's start with, let's plot the 12 municipal drinking water wells. Let's throw on the NISAC code, known PFAS areas. Let's throw the landfills on there. And let's take a look and kind of see what we get. So this is kind of what the very first step is, simple GIS exercise, something that you can do relatively quickly in like a day, pull this information. At least in Massachusetts, it's pretty well available, and EPA has some good information as well. So I don't know if it's easy to see, but there's 12 wells that are on this figure. I'll point to the landfill here if I can figure that out. So right there. So landfill's right there. There's these other little businesses up here that are potential PFAS sources, kind of shown by those little symbols that look like an exclamation mark, and then the blue monitoring wells. All right, so the next thing that we did, in Massachusetts, like I said, we only regulate 6 PFAS analytes. They're on the list right there. We call it the sum of 6. But one thing that's very important, and that we kind of figured out early on, is that just looking at whatever your state regulates does not help you with a forensics evaluation. You need to look at total PFAS, other things in there that can help you attribute other sources. So we took the information we found in the first step, just the location of the monitoring wells, these businesses. We threw on groundwater contour information regionally, to kind of see in general where's the groundwater flow. You can see the ocean, so obviously, it's flowing to the east. We plotted the septic system. That's kind of what that isoplath is. That's the septic system density. So we wanted to see, are we seeing elevated PFAS in a well that's located in a high septic system area? Maybe the septic system is controlled there. And then the last piece that we put on this was the concentrations of the regulatory standard and what the total PFAS was. And this, again, is a quick cursory review to say, okay, well, where are my higher concentrations of PFAS in relation to these drinking water supply wells? So when we did this, what we found is this guy that's got the red circle around it, that's the well that had the high detections, and it was about 5 times the regulatory standard. And all of the other wells were, somewhere in the, 4 or 5 parts per trillion, up to 15, 16 parts per trillion. So then we looked and we said, well, we have groundwater flow on this map. What's hydraulically up gradient to this? And you can kind of see, well, we've got two potential things. Hydraulically up gradient, we've got 2 municipal landfills, and we've got fire department. So we started to say, well, okay, we have two potential sources, landfill, leachate, obviously a source of PFAS, AFFF, fire department, potential source of PFAS. Through our regulatory records research, we didn't have any information about any sort of investigation that had happened at the local fire department, so didn't really have any details on what may have happened at that site. The landfills, though, we actually did have some monitoring well data, and they had recently sampled for PFAS. So we said, well, let's obtain that information, and then we can continue with our forensics investigation. So this is another map, simple overlay of environmental forensic signatures. So the map only shows a couple analytes, but when we start with this, we look at all of the 1633 analytes, so all 40-ish of them. And then we normalize the data set. These aren't concentration-based, these are percentage-based. And we plot that. For this particular data set, oddly enough, it was almost all regulated analytes. I think that there may be 1 or 2 other analytes besides the PFAS 6 that were detected in here. So for simplistic purposes, we threw, just drew the 7 or 8 that they all had in common. And you kind of get these signatures. And this is a quick way that you can kind of look at it and say, well, do I see similarities? Do I see things that are different? Can I see any sort of pattern? So when you look at these, you can see, well, I put little stars on here. They're probably hard to see, but the stars that are the same color on here are patterns that are very similar. They have repeating characteristics. Another thing that we look at too is ratio analysis. So we're also looking at percent contribution of PFOA, PFAS, kind of other things. And then we're also looking at precursors and degradation pathways, because that's very important in this too, because these signatures can change over time based on mixing with precursors or other things in the environment that can happen that can change those signatures. So we can kind of see that, well, we've got this guy, this guy, this guy, these guys, they all look really similar. Said, okay, well, that makes sense. Then we've got, these two, which are the drinking water supply wells, and they look different from each other, totally different. And then we look at these 2 guys right here, which are the signatures from the landfill, and we see that this signature right here is extremely similar to what we're seeing down gradient. They're almost the same. This signature down here doesn't really look like anything else, and neither does the one that's here. So we start to say, okay, well, we should build a conceptual site model. What may be going on here? And there's a couple of things to think about, and I'll kind of get into that in the next slides. So we take a deeper look at this. We kind of pull back and we say, all right, well, here are our 6 signatures that we got. So from this analysis, there's 6 types of signatures that we're identifying. And we kind of want to look at those in a little more detail. We want to look at what's being detected, what are degradation pathways, what analytes are we seeing in here that are similar. And we kind of came up, it was pretty obvious that the first one right here was the source of a lot of what we were seeing. So when you look at this guy right here, it's linked to these other signatures. So this is the landfill. So the landfill is causing the impacts at the depot street. These are basically identical. And then what's happening is PFAS impacted drinking water is impacting this municipal well, this depot street well. But then that water gets circulated throughout the town and gets discharged to people's septic systems. So you have a secondary background source that gets created in the area where you have a combination of PFAS coming from septic system use, our typical products that we use, as well as PFAS water that was impacted from an untreated source that's also been distributed as just your drinking water. So that's what you see with these other signatures, is that this is a transformation product of this that's been circulated around town, changed slightly because of other things being added to it. And then we've got these 2 down here, the question marks that are unknown. We don't know what those are linked to yet. So we say, all right, well, let's move on in our investigation and see what we can find out. So this is really step 5. I put step 6. I was not sure why, but this is step 5. This is kind of the final piece. So this is particle tracking. So this becomes really important because groundwater flow is general, and it'll tell us, directions that groundwater may be flowing. But there's other things that go on in the hydrogeologic area. So there's municipal drinking water supply wells that are pumping at different rates, that are pumping at different times, and it causes contaminants to move differently in the environment based on how those wells are pumping. So we ran 2 different types of models. We did a transient model, which is changes in groundwater levels and flows over time. So what that does is that actually looks at the pumping information that was given by the town. That's, for the last couple of years, it doesn't tell you what was going on 15 years ago, but most municipalities have these records now, and they keep what their pump rates are and which wells they're using and what they're shutting off. So we put that into a system, and we develop what's called a transient model. And what we can do is we can release contaminant particles at known or potential sources that we think may be the source. So we went to the landfills. There was 2 of them. And we said, well, if we released PFAS particles at this particular location, where are they going to go if the wells are kind of pumping based on what they've done on the last couple of years? So that's kind of this piece right here. And so what you see is the first landfill, the one that's up on the top here, during transient state, it goes directly to the Depot Street well. And you see this landfill that's underneath it, it goes right by it. So kind of the first thing that we say is, well, maybe this is why we don't see that secondary landfill signature in the municipal drinking water well, because it's not getting picked up by the well because the particles are moving by. And so we go, okay, well, that's kind of the first piece to it. Then we say, all right, well, what's going on at the fire department? We don't have any details about it, but we know AFFF is a huge PFAS source. I've done a lot of AFFF sites, and Legacy Foam has a pretty distinct chemical signature. And so we said, well, what's the particle tracking doing there? And that's kind of what you see down here. It has no connection to that well, and it's actually going right by the Partridge Street well, which is the second well that we were kind of looking at that had those really, really high impacts, but we don't have any signature for, and that's different from everything else. So we said, okay, well, that's what it does if a transient model. What about steady state? Steady state is where everything's the same. And usually what happens is it's not clear one way or another because things change over time. What may have happened 2 years ago is possibly not what happened 15 years ago when there was less people living in town. So you kind of have to take your information with a grain of salt and kind of look at it to see, well, what makes sense? And it's usually somewhere in the middle. So the second model is here, and this is the steady state. And again, we did the same thing. We ran the model, and both landfills show that it goes to the Depot Street well. So we said, all right, well, under transient model, only one landfill hits it, and then under the steady state, both landfills hit it. The analytical data that we have currently supports a transient model flow. We see a forensic signature that's substantially different than what we're seeing from the second location. So then we said, okay, well, it's possible then that the landfill that's been operating, since the 40s has probably been getting PFAS materials that the leachate was moving through. There was no treatment on these wells, and this leachate has been impacting the town. The water was circulated throughout the town, and that's kind of why you see this background signature that's similar to the landfill. But we still weren't sure about what's going on with this other well that's actually the well that's exceeding the regulatory standards. So we've identified that there's likely been a PFAS release from the landfill that's impacted the most downgradient municipal well that was circulating around town and that was creating kind of this background signature. And then there's a secondary source that's, the fire department or somewhere near the fire department. And during our second steady state, if you release particles from the fire department area, it goes directly to the Partridge Street well. So again, somewhere in the middle is kind of where these things flow. And it could be as simple as the release from the landfill has been going on for 40 years. The release at the fire department is relatively new, and it's just migrating there. So what did we conclude from this? And I kind of already stated what we thought. So the PFAS that we observed in the drinking water supply wells appears to have been from the landfill. And again, there was kind of multiple lines of evidence that we went through to do this. We also think that based on the chemical signatures that were in there for the secondary, for the one that appeared to be a firefighting foam, it had similar ratios of PFHXS, PFOS, and PFHXA. And similar ratios are consistent with a legacy firefighting foam. So kind of another thing that says, well, it may be related to that, but we're not sure because there's a data gap. And it also looks like there's been a large background signature of PFAS in the area just related to these releases and consumer product usage. So we kind of went back to the town and we said, well, there's some next steps we need to really finalize this and figure out exactly what happened. And of course, it's the classic consultant. We need more data. we need to put some wells in. We need to collect some samples and kind of see, what's going on. So the next steps were, targeted installation of monitoring wells. So let's go, down gradient. Preferably, you would want to drill on the fire station property, but that may not be possible for any number of reasons. Or it could be that it's an industrial facility that you can't necessarily get access to, but you can go into a right-of-way and install monitoring wells to kind of see, well, what's the chemical signature look like there? And then you can kind of backtrace things. We had targeted installation of monitoring wells in other locations too to fill in the data gaps, as well as collection of additional groundwater samples for analysis using 1633. And then when sufficient data was available, we would have a more concise picture of, is our conceptual site model correct? Is there something that we're missing? Could be possible that the fire station wasn't necessarily the source. It could be as simple as they responded to an accident 15 years ago and that they had sprayed firefighting foam and that got washed into a catch basin. And that was the source of PFAS that we were seeing. We know it takes a real long time for PFAS to migrate through the subsurface and to get into groundwater. So it could be that this had happened. So with that, we doing questions now, or? Yes. All right. Happy to take any questions if anybody has any questions they'd like to ask.
Does anyone have questions? Okay.
Thanks, Brian. That's a very good presentation.
There's one question here, I think.
There's one up here too.
Yeah, I'll go first. Thanks. So you mentioned about one of the wells in the southeast portion of your project area. It is next to a septic system populated sites. Have you ever looked into those signatures from the septic systems, or do you have any result of that?
So we have, and the septic system densities, it was hard to see on the map that showed the densities. They are adding to it, and the signature that they were adding to it wasn't really showing anything significantly different than your typical like PFAS type additive to it. But we did absolutely look at it because it was one of the first things in our model is that septic system usage can be a significant source. And oddly enough, in that red area on the map, which was the higher density septic systems, there were elevated concentrations. So we were originally saying, well, maybe this is related to septic system, but when you look at the density numbers, they're deceiving. It's not like it's 10 times higher in that particular area. It's more like it's like 1.5 times higher because it's not really a very densely populated area to begin with. Great question, though.
It seems like a really tricky problem where your background and landfill and well have all such similar signatures, and I think your conceptual site model seems like a pretty good explanation for that. But did you think about maybe going outside of the municipal service area to try and get a background sample from maybe somewhere that the town well didn't serve to maybe establish that a little bit better, where if you didn't see that background signature just outside of the municipal service well, that would kind of be a smoking gun? Did you look into that at all?
So we did. Great question. One of the first things that we do when we do a PFAS investigation is we figure out what background is, because you could start doing an investigation, identify PFAS on the site, and it not even be related to your site and be background. So two of the municipal supply wells that are in this area are located on the hydraulic upgradient end of the property. So we were seeing similar signatures on that end as well as, miles away. But we did not have data to see what does the municipal wells look like in the next town over, to see if their signatures are similar. Because we are the last, that was the last town before you get out to the ocean. So that would be a good part of kind of the second phase, is to see, well, is there anything else that's coming onto the property? And for the purposes of what we were looking for, we were seeing very, very low concentrations of PFAS coming, from the hydraulically upgradient most portion of the town, relatively very low, and then extremely high concentrations, right around the landfill and around the fire department. So we kind of concluded that these other locations were actually representative of background. So of the 12 municipal drinking water wells, 10 of them were background. And background is kind of defined as your atmospheric deposition, your consumer product usage from the septic systems, as well as the use of municipal drinking water that in this particular situation had received PFAS from a release. So not necessarily true background. It kind of gets complicated when you throw in this discharge to septic systems, because then you say, is that actually a result of a release? And it's true that it is, we use the term background to show that these wells aren't the source of anything, that they're receiving from others.
Any other questions? Okay, thank you.
Thank you.